Alright guys, welcome to Audio Essentials. Today we're talking about harmonics, or the harmonic content of a audio waveform. So first of all, let's hop over here to Logic, and I'm going to play you a few examples of different harmonic content. So to start out with, we've got down here on track 3, let's zoom in on this. So we have a generated sine wave at a frequency of 130 Hertz. This is what it sounds like. Okay, and if we look at our equalizer, you can see it's only right here at exactly 130 Hertz. There's nothing else going on, no other frequencies. I could boost this up, doesn't do anything. So this perfect sine wave has no harmonic content. It's just that one frequency and that's it. But these things do not happen in the natural world. This is computer generated. It can also be electrically generated, but there's no instrument that is going to make a perfect sine wave like that with no harmonics. So let's mute that one. And here, on the other hand, is the same note being played on a piano. And as you can see, this is not a perfect sine wave. There's all kinds of little bumps and crags and wiggly stuff going on. And let's hit play on that. And that actually sounds like a piano, right? Not like some electronic thing. Now, if we look over here, so it is hitting at 130 Hertz, but there's also all kinds of other frequencies going on. And we can go in here and boost them one at a time. So I'm going to narrow this down first of all so it just isolates one frequency. And let's boost this up. So if I put that right at 130, see how it boosts just that one tone? So this is called our root note, or the first harmonic. Then the second harmonic, you can see this next peak over here. So let's bring this up. You hear that being emphasized? So it's actually an octave above the root that we were hearing. So right here I'm hitting a middle C on the piano. And then this note that's being played is the next C note above that. Then I could go up here. This is at 390 Hertz. Can you hear that? And then this is that next C, another octave above. All these notes sound kind of right, huh? Except this one. This one's kind of weird. This is the 7th harmonic, and the 7th harmonic is not part of the C scale. And then at 140, I think, yeah, there's the next C. And it keeps going. Now let's turn that off. So, even though I'm only hitting the C note on the keyboard, all of these other notes are there in the waveform. And they get more and more quiet as it goes on, but this is what makes a piano sound like a piano. If I switch this to a violin, it would still have all these notes, but they'd be different relative levels. If I switched it to a human's voice, same thing. But so it's the harmonic quality that makes it sound like the distinct instrument. Let's pause this. So let's go into how this works over here. So let's say my C note was, move to my drawing pad here. So that was 130 Hertz was the bass note. Now if I wanted to figure out the harmonics of this, here's the equation for it. So the harmonic frequency equals the root frequency times the number of the harmonic that you want. Okay, so if my root is 130, and I want to know what's the second harmonic in that series, well, 130 times 2 is 260 hertz. And so if I went back to this waveform here, so here we are at 130, and then if I change it to 260, that should be that next peak. Yeah, there it is. Okay, then what would be the next one beyond that? So if my root was, let's move this up, if I want the third harmonic, 130 times 3 is 390. Let's see if that's right. So let's type in 390 here. Yep, that's it. Okay, so harmonic frequency equals the root times the number of the harmonic we want. Okay, so you guys try this one out. If my root is 100 hertz and I want the third harmonic, then 3 times 100 would be 300 hertz. So starting with 100 hertz, we can figure out all of our harmonics. So this would be the first harmonic, second, third, fourth, fifth, sixth, seventh, and eighth. Okay. Now, if you want to figure out an octave, let's move this up here. An octave, this is like the same note but one higher. So the octave the octave frequency equals the root times 2 to the power of the number of octaves that you want. So if I want the first octave, that would be root times 2 to the first power, which is 2. So in this case, 100 times 2 equals 200. So this one is an octave above it. And then the next octave above that is 400. And the next octave above that is 800. So here we have 4 octaves, and then these other notes will fill in the other notes of the scale. So let's try this with our little generator. I'm going to do it at increments of 100 hertz. Okay, now we're hearing it. So if I go, what? So if I'm starting at 100 hertz, this is what it sounds like. Okay, so let's go to the next harmonic, so 200. So that's one octave above, right? Then we can go to 300. 400. Whoa, actually let's turn that off. 500. 600. And then this is the 7th harmonic, so it's going to sound off. This one's the one note that's not part of the scale. There we go. Okay, so that is how harmonics and octaves work. So use these equations when you need to figure out your harmonic content. And octaves also work the opposite way. So if we want to know what an octave below 400 Hertz would be, you can just divide that in half. So 200 would be an octave below that. So try this out with your homework, and we'll see you next time.